So in this class, we will wind up photoelectric effect. We have discussed all the points that we had to discuss. We had also seen all the things in one slide. We had seen the meaning of work function, threshold frequency, threshold wavelength, and we had seen on what all factor what depends on. Intensity means the number of photons. If number of photons are more, current is more. But current can only flow when the frequency is more than the threshold frequency or wavelength is less than the threshold wavelength. We remember all these points, yes or no?
Yes, sir.
More likely, the question that you are going to have, if it is an theoretical question, it will come from all these highlighted points or it will come from the 4 or 5 graphs that we have done. Now let us move on to the questions where you might have numericals. So to solve those numericals, we have an equation, and that equation is known as Einstein's equation. Einstein's equation. And this is the equation for which he got the Nobel Prize. Do you know this equation for which he got the Nobel Prize? What is that equation for which he got the Nobel? Huh? What is the equation for which he got the Nobel Prize?
Equals to mc square.
No, that is not the equation for which he got the Nobel Prize. That is the equation that is famous, but he did not get Nobel Prize for that equation. He got Nobel Prize for the equation that we are studying. So this Einstein's equation is based on law of conservation of energy. This Einstein equation is based on law of conservation of energy. Now, Einstein said that light consists of photons or particles. When this particle falls on electron may absorb their energy, get sufficient energy, and they can move out. If let us say, if we say that E is the energy of the falling photon, which can be written as h into f, where f is the frequency of the falling photon. Now what will happen? Some part of this energy will be required to remove the electron. W is that energy, or W naught is the work function. So some part of energy goes in removing the electron. Some part of energy will be lost in the form of heat. The electron may collide the photon. When it falls, it may lose some energy due to heat and light. Then the remaining energy will come in the form of kinetic energy of the photon. This equation is known as the Einstein's equation. Now, if I put a special condition here that if there is no loss of heat energy does not get lost anywhere. By getting lost, it means it does not get converted into forms which are not useful right now. If there is no loss of energy in the form of heat, then I can write this energy HF that falls on the photon, HF, the energy of the photon which falls on the electron, will be equal to the work function W naught plus the maximum kinetic energy. And this equation became the Einstein's equation for which he got the Nobel Prize. Do we understand this?
Yes,
Not
sir.
for E is equal to mc square, this one. Do we understand this? Yes or no?
Yes, sir.
This is known as Einstein's equation. Now, we can remember this equation in a variety of forms. For example, I can write this work function as h into f naught. I can write this kinetic energy as half V max square. This is one more way of remembering the same equation. Equation number 1, equation number 2. Now, I can also remember it in other forms. Instead of writing kinetic energy as half mv square, I can write it as E into V naught, where V naught is the work function. Form number 3. I can also write instead of h into f, I can write h into c by lambda is equal to hc by lambda naught plus E into V naught. Question number 4. Or I can simply write it as total energy is equal to W naught plus KE max. You understand? I know KE max can be written in 3 different ways. I know E can be written in 3 different ways. I know work function is written in 3 different ways. Therefore, I can write this equation in a lot of ways. You just have to remember any one and you will remember all. Do you understand this? Yes or no? No, yes.
Yes, sir.
Huh? I'll give you 2 minutes to note this down. Note it down aram se, because we are done with the chapter. We only have to now do problems based on this equation. So the more the number of ways that you remember it, the more the number of questions that you do, that is all that you need, and that is what we are going to do in today's class. And we will move ahead of those kids from the JEE section, because we will be finishing this today. They will be finishing it tomorrow. They could not do the required number of questions today, so they would be finishing it tomorrow, but you can finish it today if you can do the required number of questions quickly enough. If not, then you will be in the same class as the JEE ones.
Done, sir.
Well done, sir. What about the boys class?
Completed, sir.
Boys class also has girls voice. Good. Girls everywhere. Okay. Where I was. Now, okay, I have to move ahead. Now, we have written this equation in various form, and I showed you one more graph. I'll show it to you again, because now once we have a look at this, we will understand this graph. Which graph? This graph more nicely. The graph between kinetic energy and frequency. So you can write the heading as graph between kinetic energy and frequency. Graph between KE max, you must write KE max and frequency F. Now, how does the graph look like? And no prizes for guessing this one. Now, you might be what medical student by hope. You understand how does a straight line look like, and you understand straight line, no?
Yes, sir.
Yes, sir. Then this is the graph, sir. See, this is how the graph looks like, and I had shown you this graph before also. Now I can write the formula for kinetic energy as h into f minus work function. Do we understand this? So
Yes,
this is
sir.
in the form of y is equal to mx plus c. Do we understand this? Y is equal to mx plus c. It is in the form of y is equal to mx plus c. Do we understand this better? Equation of a straight line.
Yes, sir.
So the slope of this graph becomes h. So tan of this theta for any will be equal to h. For any metal, whether it's metal A or metal B, they will be inclined at the same angle. This question has come many times in your NEET. They will be inclined at the same angle, but their y-intercepts would be different. This is the work function of the first metal, because it is minus omega naught, and this is the work function of the second metal. Here, work function of the second metal, metal B, is more than the work function of the first metal A. Do we understand this? Yes or no?
Yes,
Graph
sir.
between kinetic energy and frequency of falling radiation. Slope is same. Y-intercepts are different. I'll give you a minute to note it down.
Completed, sir.
What about boys? Boys have completed or girls have completed? Girls have completed. I mean, girls class has completed. Shall I move ahead? No, boys are still writing, so I'll have to wait. Write it, write it. You just have to do questions after this. Nothing else is left. We are done with the entire chapter. Trust me.
Completed, sir.
Completed, sir. Then we move ahead, sir, with the next graph. This was a graph between kinetic energy and frequency. I've also shown you the graph, I think yesterday, but since now we know and understand the equation, I will show you the graph and we will do the graph once again. And that graph is between stopping potential and your frequency. So you can write the heading graph between, we have already done this graph, but still you can write it, graph between V naught and F. And how does this graph look like? I will again show you the equation, because now we know Einstein's equation. Remember, this is the equation for which he got the Nobel, not for E is equal to mc square. He never got a Nobel for that. Got the Nobel for this one. Okay, now this is the graph between stopping potential and your frequency. Remember, I can write the formula for work function W naught as HF sorry, I can work, I don't have to write it in the form of work function. I can write the formula for V naught as, V naught is the stopping potential as HF by E. I have divided it by E minus work function divided by E. Yes or no? Now, if I again compare it with the equation y is equal to mx plus c, your slope of the graph m becomes h by e, which is here. So tan theta of any metal will be constant. This is the frequency here and this is the stopping potential here. The y-intercept would be different. One which has more work function. It is similar to the graph that we have shown. The only thing is it has been divided by E. Do we understand this?
Yes, sir.
Same graph was divided by E. I'll give you 1 minute to note this down. This graph has come more than once in your NEET. More than once. Either this one or that one. So if you can remember this graph, this is all that you need to do. Now we have to just solve questions. And dear, we are done with this chapter. You have that sheet that I have sent you, beta. I hope you are doing questions on that sheet. That sheet has a photoelectric effect. That sheet has matter waves, and that sheet has X-rays as well. X-rays is the next topic. So if you can complete that sheet by Saturday or Sunday, or after Sunday, we'll move on to the next topics of modern physics. We'll probably finish your semiconductor, diode, and all those things. There are simpler topics. We can wind them up quickly in a week or so, 10 days. You should be able to finish your entire modern physics. And that will give us some confidence moving ahead, because we have done some part of the portion. Only electro will be left, which we will cover eventually.
Done, sir.
Everyone, sir? Boys, done? Boys,
Ready,
done?
sir?
Completed? Okay.
Yes, sir.
Now we just have to solve some problems and we will start from which one? Let me see which is the problem that we should most likely start. And remember, most of these problems I have discussed with your mains student as well. I mean JEE student as well, because similar problems have come in both the exam, JEE Main as well as NEET. So here comes the first one. And let us solve. The more the number of problems we solve, the better we are. And I will try to cover all types of problems that have come up till now. The work function of a substance is 4 electron volt. The longest wavelength of light that can cause photoelectric or photoelectron emission from this substance is approximately how much? You have 2 minutes to solve this. And I hope you can do better than those guys. You can do them more quickly than your maths counterparts.
Sir,
Yes, bacha.
option C, 310 nanometers.
Option C, 310 nanometers is absolutely correct. Well done. Option number C is correct. Boys, did you get the answer? Or you are still looking here and there? Huh? Boys are still looking here and there. Girls have got the answers. How did you do it? Yes.
So work function equals to Hc by lambda naught.
Yes, you just have to put the values, get the answer, and stay happy. So, how to stay happy here? Work function W naught, it's Hc by lambda naught. Lambda naught becomes Hc by work function. Remember, you don't have to multiply H by C. You should remember that H into C is 12,400. Work function is in volt. Electron volt, remember it is given in electron volt, so just divide it by 3. You will get 3,100, but that will be Armstrong unit. You convert from Armstrong unit, it is 10 to the power minus 10 into Newton nanometer. Your answer will be this. That is as good as it gets. Do we understand this? Yes or no?
Yes, sir.
Simple questions. You just have to multiply, divide, and you are done. Boys, do we understand this? Boys class, do we understand this?
Yes, sir.
Were you able to do it, sir?
Yes, sir.
Well done, sir. Then next question, sir. Let's see who does it fast. This is the next question. Photo energy, photons with energy of 6 electron volts are incident on a surface of work function 2.1 electron volt. What is the stopping potential? Question number 2. Let's see who gives me the answer first. I'll give you 2 minutes. Anyone with an answer? Shall I do it?
So 1 minute.
Okay, I can wait for 1 minute. I have that much of patience. Don't be shy. Yes, Aviram, tell me the answer. Aviram is saying some things. Did not see. 3.9. Yes, Aviram, 3.9 is correct. 3.9 minus 3.9 because it is negative potential, so we'll call it minus 3.9. That is the answer, my dear friends. Don't worry. Questions are so simple. What do you think is the correct answer, beta? So how do you get this? Question number 2. Solution. Total energy is work function plus the maximum kinetic energy, which is E into V naught. Yes or no? So
Yes,
E
sir.
into V naught becomes total energy minus W naught. So it is 6 minus 2.1, 3.9 electron volt, electron. It gets cancelled. So your stopping potential becomes 3.9 volt with a negative sign because it is negative with respect to the cathode. Do we understand this? Yes or no? No, yes. How many of you got this? Everyone got this? See, questions are so simple. I'll just give you, do it fast. The more the questions that you do better, the better it is for you. This is a question from engineering exam, but I think you can do it. If you can do this, that is the toughest question that can come for you guys. Question number 3. This is the toughest one that can come. If you can do this, the rest of them are very simple. So we'll do it whatever. We have got around 20 minutes, and I think in around 20 minutes we can solve around 8 questions. If you can do 8 questions, we'll cover everything that can come for you guys. I'll give you 2 minutes to solve this one. When radiations of wavelength lambda falling on a metal surface, the stopping potential is 4.8. The same metal is illuminated by a wavelength 2 times lambda. The stopping potential is 1.6 volt. What is the threshold wavelength lambda naught? Yes, anyone with an answer, bacha? Shall I do it? Huh? Shall I help you? Okay. Shall I do it?
So 1 minute.
Okay.
So 4 lambda.
4 lambda is correct. Well done. 4 lambda is correct. How did you do this? Well, just have to find the formula for stopping potential. You can write this formula of stopping potential. That will be equal to Hc by E into 1 by lambda minus 1 by lambda naught. Yes or no?
Yes, sir.
You can write this Einstein equation in this way. Remember, the more the number of ways in which you can remember the equation, the better you are going to be. So in first case, what you do, stopping potential is 4.8 Hc by E into 1 by lambda minus 1 by lambda naught. That is the first equation. For second equation, stopping potential is 1.6 Hc by E. Lambda becomes 1 by 2 lambda minus 1 by lambda naught. Now you divide these two equations and I'll tell you something about the calculation. If you divide these two equations, this will go 4.8 divided by 1.6. You will have 3 on the numerator on this side. That will be equal to 1 by lambda minus 1 by lambda naught divided by 1 by 2 lambda minus 1 by lambda naught. Yes or no? So if I cross multiply 3 by 2 lambda minus 3 by 2 lambda naught will be equal to 1 by lambda minus 1 by lambda naught. You take terms on one side and you should get your answer. Yes or no? And I think you will get lambda as 4 times lambda naught. You just have to calculate it. Yes or no, bacha?
Yes, sir.
Oh,
The lambda naught equals to 4 lambda.
here I have done a mistake. This is lambda naught. 3 by lambda naught. Yes, beta. Lambda is equal to 4 times. Sorry, ulta I have
Lambda
written.
naught equals to 4 lambda.
Yeah, I have written it wrongly. Lambda naught is 4 times lambda. Do we get this, everyone?
Yes, sir.
This one is the next one. Give you 2 minutes to solve this. Again, it requires some calculation. If you can get the calculation done correctly and quickly, you are done. 2 minutes you will have. An incident is when radiation is incident on a photoelectron emitter, the stopping potential is 9 volt. If the E by M, charge by mass ratio for the electron is 1.8 into 10 to the power 11, find the maximum velocity.
Sir.
Yes, beta.
Once you go back, sir.
Once I go back, sir, here. Okay. What is the problem here, bacha?
1 minute, sir.
Okay, sir. Noted it down, sir?
Completed, sir.
Then the next question, sir. Radiation is incident on a photoelectric emitter. Stopping potential is 9 volt. Charge by mass ratio for electron is 1.8 into 10 raised to power 11. What is the maximum velocity? This question has come in your NEET also. Try it. Yes, bacha. Anyone with any answer?
So 1 minute. Sir,
Yes, beta.
sir, option C.
Option C. C is correct. C is correct. How are we supposed to do this? You must know that the maximum kinetic energy half mv max square is equal to E into V naught. Yes or no?
Yes, sir.
So you can write the value of V max as root over 2 E by M multiplied by V naught. You can now put the values and you just need to calculate it. 2 into 1.8 into 10 raised to the power 11 multiplied by V naught is 9. 2 into 9 is 18. You can write it as 1.8 into 10. So 10 raised to the power 11 becomes 10 raised to the power 12 and you will get Answer as option B. Do we understand this?
Yes, sir.
Everyone understands this?
Sir, option C, sir.
Oh, sorry, not option B, option C. Okay, we got this?
Yes, sir.
Okay. Okay. This is the next question. The lowest frequency of light that will cause the emission of photoelectrons from the surface of the metal work function is given as 1.65. What is the lowest frequency? It is all about your calculations. Okay. So solve it and give me the answer. Solve me and give me the answer.
Hello, sir. Hello,
Hello?
sir. Hello,
Yes.
sir. I am Naresh, sir. What happened, sir? Anything wrong?
Who is giving me instruction in the class?
Who is that, sir?
Who has got the authority to give me instructions?
I
Who
think
is sending me message?
some student. So
I
we are
don't know. I'm getting message from this.